Mm. And this improves speed but adds some complexity. Now let's take a look at how the advanced techniques work. And with that, we'll briefly touch on 2 or more techniques. And one is the prefetching. With this one, the system guesses what data you need soon and loads into the cache early. So with the prefetching, we have 2 types, and that is the software prefetching and the hardware prefetching. So now let's take a good look at how prefetching matters and why it really matters. The goal of the prefetching is to reduce cache miss penalty, and then it is also used to trigger predicted memory access pattern. The prefetching is done by the hardware, that is automatically, or by the software, that is manually. Prefetching is best used for loops, sequential reads, predictable data access, and the risk applied or the risk involved in prefetching is the cache pollution, memory risks, and wrong predictions. And our next section also will deal with how prefetching is used in our real life. Prefetching is used in CPUs, that's the Intel and the AMD. The next one is GPUs, that's mainly used for the gaming textures and the frames. Also used in web browsers. It aids in loading next page content in advance, and it also helps mobile apps for preloading features for speed. And then the last one is for the AI systems, preloading model weights or layers. And then the second technique is the multi-level caching. Most modern CPUs use multiple cache levels, that's the L1 and L2, and sometimes uses L3. The L1 is the fastest and closest, but smallest. L3 is larger. L3 is larger and shared between cores, but that one is also slower. The last aspect is the set associative mapping, and with that one, it's a middle ground between direct and fully associative. So, someone will ask, what is the definition of a set associative mapping? The cache is divided into several sets, and each memory block maps to a specific set, but can go into any line within that set. Let's take, for instance, in a 2-way set associative cache with 8 lines, we have 4 sets, each with 2 lines. Then the block 8 might map to set 2. Within set 2, it can go into either of the 2 lines. To sum it all up, memory cache techniques play a crucial role in ensuring fast, efficient data access in computing systems. Through intelligent mapping, replacement, and write policies, along with advanced strategies like prefetching and multi-level caching, systems can reduce access time, improve throughput, and enhance overall performance as technology advances. These techniques continue to evolve, making them a fundamental concept for anyone studying computer architecture or computer optimization. Thank you all for listening. To conclude, direct mapping is fast and simple, but can suffer from many conflicts. And with a fully associative mapping, it gives the most flexibility but needs complex hardware to be able to function. And then with a set associative mapping, it strikes a balance, offering better performance with manageable costs. Choosing the right mapping depends on the performance needs, budget, and use case of the system. So with that, if you want to go with a set associative mapping, you would have to look at the performance that you need to do it, and then how the budget is also accumulated to, with the use of what and how you are going to need your data and how you want your data to be stored and to be used. Thank you for your attention.